Awesome. Thank you so much for having me. I'm going to talk a bit about CI and CD for machine learning and AI. This is a collection of thoughts. I'll give some context, and hopefully it kind of sparks an interesting conversation. Very quickly, my name is Dillon. I run a company called Paperspace. We have been around for about 4 years in the GPU infrastructure space. So that has meant a lot of things over the last 4 years. To date, we are a team of 33 people spread around the world, mostly here in New York. Developers in New York, Poland, Copenhagen, Amsterdam. We always get asked where the name Paperspace comes from. It's an old architecture engineering term that we liked, and the domain was available. So over the last few years, there's been kind of a huge shift in GPUs. For those not familiar with it, these are graphical processing units. NVIDIA is the biggest manufacturer today. And basically, they shifted from the visualization or graphics pipeline into the compute pipeline. And as this has happened, we've seen the emergence of lots of interesting technology, from blockchain to the biggest one that I think about, which is the machine learning and AI space. So being in the kind of GPU infrastructure space for a while, we've been thinking a lot about machine learning. And we actually have a product called Gradient, which is a tool stack built for machine learning developers. And our goal is to accelerate AI adoption by enabling data teams to quickly and efficiently develop, train, and deploy deep learning models. But I'm actually not going to talk about Gradient too much tonight. Instead, I'm going to talk about kind of what are the motivating kind of factors that have led to why we've been building Gradient, and also some challenges in the space. So quick outline, I'll talk about sort of the current state of machine learning infrastructure, the shift from DevOps to AIOps, going through some kind of existing CI/CD workflows, talking about how those don't really fit anymore, and then making the case that these new pipelines are fundamentally different and require new tools, new workflows, and generally like new paradigms. So at the core of this is the idea of kind of core primitives for these pipelines, and I just want to distinguish the primitives of a pipeline from the primitives in an AI algorithm. So if you're an AI or machine learning or deep learning developer or researcher, you think of your primitives as hidden layers and LSTMs and things like that. From an infrastructure perspective, it's actually much higher up. And so I am not an AI researcher. I don't think about I don't think often about sort of the fundamental kind of algorithmic shifts that are happening in this space. But instead, how do you go from training these models and doing amazing things with 100 lines of TensorFlow and actually deploying that and making something interesting out of it that that people can use. So shift my notes here. So where are we today? And so my perspective is outside in. I'm looking at it from a infrastructure provider and infrastructure kind of thinking through networking, systems, application development, instead of sort of research and AI. So the current state of infrastructure is that not to say there isn't any tooling, but most of the tooling is kind of home rolled. Best practices haven't emerged yet. We're seeing a lot of, especially large companies, roll their entire own stacks. So Facebook has FB Learner, Google has TFX, Uber has Michelangelo, Airbnb has Big Head, and there are a bunch of these that have kind of come out. Databricks has one. Every day there's a new kind of pipeline. Intel came out with one like 2 days ago. And it kind of looks like the 90s web development, where everyone's rolling their own solutions, which is a little bit weird, especially for something as advanced as kind of deep learning and machine learning. And so there are hurdles to productionize these things. So what we've seen, I would say, over the last couple of years, the primary use case for developers on Paperspace and our tool Gradient have been kind of developing deep learning models or playing around with them. Now they're finally getting to the point where they actually want to deploy them, and they're wondering, how do you do that? It's relatively easy to train something on a GPU rig in your office, not so easy to actually turn that into a production system. And then at the core of all this is actually something really interesting if you follow the space around hardware. There's a whole lot of new hardware. I think a few $1 billion have been invested in new hardware startups. There are a few unicorns already for companies that don't have products fully out yet. But it's super interesting. So all the big guys, NVIDIA, Intel, AMD, GraphCore, Cerebras, there are hundreds of these that are working on new hardware. And when you think about new hardware, there's a big shift in how we think about sort of the pipelines and how they're developed. So this is the current state of the art. You kind of pick a GPU, put it in a machine, you ask your developers to start building something. It's kind of like running a web server by yourself when you learned web development in the 90s or whenever you learned it. And so what that means is traditional web services are, there's a lot of tools around that. Accelerated sort of machine learning, AI, data science, that kind of thing. There really aren't a lot of consolidated tools. So I'm going to make the case that the biggest barrier to adoption is an infrastructure and tooling problem, not necessarily an algorithmic problem. I think if you go to NeurIPS, formerly NIPS, or any of these other conferences, the algorithms are really amazing. Deep learning can do really phenomenal things, but actually making that useful or making someone who's not a deep learning expert able to use it is really hard. And so there's kind of this huge barrier between business objectives and like the raw tooling. So I can give you a bunch of GPUs and a bunch of data and tell you to turn that into something interesting. Not super easy. Sorry, this diagram's really small, but the good thing is, there are patterns that emerge. So this is just a kind of generic pattern for data pipelines as they exist today. It doesn't have to be deep learning. It can be just traditional machine learning. But long story short, you have data coming in, you compute it, you kind of build a model out, and ultimately you want to deploy it. And so if you look at this, you kind of zoom out and cross your eyes, what you see is, a CI/CD pipeline. So what I'm talking about is, DevOps, which now sometimes we talk about GitOps, which is a kind of very deterministic way of building code and having that deploy into something called AIOps. And a lot of the kind of lessons here or thoughts are based around how we've been developing Gradient and sort of our thinking around the space. So real quick, CI/CD stands for continuous integration or continuous deployment or delivery. Oftentimes kind of conflated, and actually I will do that for most of this talk, but generally they're not the same thing. Continuous integration has to do with testing your web application or your application, profiling it, building it, packaging it, that sort of thing. And then delivery or deployment is very much about sort of how you serve it to the world. I'm going to collapse these two for the purposes of this conversation, but I think there are some nuances that are worth talking about. But why do you care about continuous integration or continuous deployment? You care about it because it adds reliability, reproducibility, determinism. Your systems are no longer inscrutable, which is a very big criticism, especially of deep learning architectures, which is that they're black box or they have an interpretability kind of problem. So if we look very high level, and this is a work in progress. I think this is kind of a straw man, but it's worth designed to kind of motivate the conversation. So traditional kind of continuous integration and continuous deployment, the idea is you have sort of this single primitive called code. It works its way through the system. We use Circle CI or Jenkins or something like that. But generally you build test or test build, then you deploy it. It's very unidirectional. And some interesting things about it, it all runs on Intel or x86 architecture. It's pretty vanilla. The system can happen pretty quickly. We build our web app in, like 6 minutes or something like that. And so you can iterate very quickly. So this is sort of a generalized version of a kind of ideal deep learning or ML pipeline. And the idea here is just to highlight some big differences. So the first one is, it's not just code anymore. It's actually data. Okay, so if we now treat data as a first-class primitive in this system, then that actually means that the system opens up in really interesting ways. No longer can you just sort of test it, build it, and send it out. You actually have this training step in many cases that's very long, and you want, sort of in your ideal CI/CD system, you actually want to be able to break out of a training task if it's failing in the middle of it or something like that, which is not a primitive that a Travis or a Circle CI would actually build in, at least not for a web application. And then the other thing is that this is running on all sorts of exotic hardware. So we're talking about not just Intel, x86, we're talking about GPUs, IPUs, TPUs, ASICs, FPGAs. It will, my guess is by the end of the year, there'll be 10 more new devices that are coming out. And then ultimately, if you think of traditional web development as sort of a unidirectional process, the holy grail here for everyone working in this space, whether it's for financial modeling or for fraud detection or anomaly detection for security cameras or driverless cars, you really want a feedback loop where actually the output of the system is feeding back in interesting ways. And so, what are those four differences? These are how I think about it. I think this is up for debate. I want someone to say I'm totally wrong, but generally you have a new primitive called data. You have new accelerators that are at the basis of this pipeline, so you can't just containerize it and send it anywhere in the world. This training step takes a while. We run workloads for customers that can go up to like 3 weeks for a training task, and continuous in the sense that for a web app, your feedback loop is usually a customer complaining about something, and then you've got Jira tickets or something. In a kind of modern pipeline, you actually have this continuous feedback loop. So where does this lead us? I mean, this is where I'm thinking a lot right now and working with my team, just kind of trying to wrap our head around sort of what are the new semantics of these types of systems. There are new concepts like data governance, data versioning that come into it. The things that come out of it are different. You've got artifacts, you've got new places to deploy these models, whether it's the edge or the data center. And then what are the triggers? And I think a lot about this right now, which is when do you want to actually retrain a model and how do you build out the systems to do that? So, I added one called code drift there, which arguably is the only trigger for most web apps. Your code drift, someone adds something, you rebuild your model, which is your web application. But actually what you care about in these newer systems is data drift or model drift. If your data changes substantially, you probably want to, retrain your model, at least refit it. If your model drifts from, your observations from what you actually expected, you probably want to retrain your model. And so these are the types of semantics that don't really make sense in traditional systems. There's an interesting example I think is worth looking at called Concourse CI, which is, they call it a generic thing doer, which gives a nice language around sort of how you think about these things. And so some just conclusions and some claims that, this is where we're thinking, but generally I think the tooling has to accommodate more complicated semantics. So the reality is, you can't really smash a deep learning pipeline into a traditional web application framework. There are just too many fundamental differences. An interesting thing that we've seen emerge is kind of this idea that, in places where the gates in a web application that are binary, so say pass, fail, your code, your test passed or they didn't, are giving way to kind of newer paradigms. So this is an example called CodeCov, which is a company that does much more sophisticated kind of Git hooks on your code, not machine learning related, but basically you can have a richer syntax around when you let code come into your code base. You might say, if code coverage goes down by 10%, let it in, otherwise don't let it in, which is different than saying, pass, fail. Tools in this space, this is an observation. I'll check back in a year or two. We'll see if I was totally wrong. We'll go wide and deep to close this AIOps feedback loop. So by that I mean you'll see more kind of platform, kind of large-scale tools to design out these pipelines, and also in each step of those pipelines, kind of deeper areas around experiment management or model profiling or compiling models. And then I think also one of the weird things, and I don't know if I phrased it the best way here, but from a software perspective, I think the edge of the data center will merge, and I also think that that hardware will also be almost entirely abstracted away by these platforms, which is going to be an enormous mountain of work that will be done by lots of companies. I think we will do some part of it, but there will be a lot of companies working to, at the kind of runtime of the machine learning model, which is how do you get it to run not just on NVIDIA GPUs or whatever, and a certain FPGA, and actually get it to run on iPhones, Android devices, et cetera, et cetera. So this was not a shameless plug about Gradient, but we are shameless plug for, we're actually accepting applications for anyone who is interested in this topic for researchers this summer. We've got 3 positions, 2 are filled. If this seems interesting and anyone wants to kind of geek out on this for a summer, reach out. That's it. Thank you. This one.
Oh, thank you very much.
Yeah.
Very interesting. I guess sort of the obvious question is, why a separate company as opposed to a cloud provider, as cloud providers tend to continue to expand their offering in core infrastructure. How do you guys think about that?
I mean, that's a hard one. I think that,
I thought I would start with a hard one.
Yeah. How do we beat Google, Amazon, everyone else? I think that it's fundamentally not a cloud provider problem. I think that cloud providers are investing in specialized hardware that they want you to kind of buy into their stack. I don't think it's a problem for a lot of companies. I think if you want to use TPUs and TensorFlow and Google machine learning tools, then you can stay in that ecosystem. I think that being able to run these in an agnostic way across clouds, across hardware. I mean, we know that all the big cloud providers are investing in hardware, and I think that it's what looks like a hardware infrastructure problem that makes sense for cloud providers to take on is actually a product problem or a software problem, and that's I think that's why we think it's worth working on.
What's expected on the customer side in terms of team capabilities?
Yeah, I would say, for us, we are very much a developer-focused platform. So most of our, the longer tail of our customers and people we interact with are researchers, developers, small teams at startups. The biggest teams generally don't go much larger than, say, 15 to 20 people, especially in the deep learning space. I mean, there might be bigger ones, but usually we don't interact with much larger than those. So yeah, I think the sweet spot is these teams are growing as well. I think what was in the lab as sort of a research project is now turning into how do we make this production ready? And that's the big trend for basically training to inference over I'd say 2019.
Very good. Just one last question from me, and then we'll open up for some questions.
Yeah.
From you guys, maybe tell us a little bit about the business aspect of this, the commercial, the go-to-market, who's an ideal customer, or how did you start build the customer base?
So we, I kind of mentioned at the beginning, we came at this from running GPUs in data centers largely. And, over the course of the last few years, the biggest group that has kind of come, or basically the two biggest groups were, crypto miners and machine learning practitioners. One of them actually really needed compute. The other one just pretended to need compute. And so, we've been, for the last 3 years, kind of seen this space evolve. And, I do believe that the challenges here are mostly infrastructural. So our team is not really, deep AI practitioners. It's mostly systems engineers, network engineers, people that are kind of looking at best practices from software development methodologies and trying to apply that to this emerging space that has, data scientists, mathematicians, statisticians, and people that aren't, traditionally versed in, software development methodology, which is different. I think you see a lot of vertical AI companies coming from, a PhD in AI with a vertical focus that will do really well. And what we're trying, and that was sort of the point about wide and deep. I think there are companies that are going to go super deep, and I think we're interested in sort of the wide as well. So
very good. All right.
Yeah, thank you.
Questions? One here.
Thank you. So in terms of CI/CD, traditionally reusability is key. What's your thinking in terms of pipeline reusability and also model reusability, model catalog? How important is that in your business experience?
Yeah, I think that's one of the fundamental unsolved problems in the space right now. Like, there's no good model zoo or model repo, and almost every company that I've worked with has their own version of that, and it can range from a Dropbox folder to actually repurposing Travis to actually do that. It's not Git. I think that's an important thing. It's also not a traditional kind of experiment tracker. It's somewhere in between. Git doesn't care about let's give one example. A hyperparameter search. Does every run of a hyperparameter search mean a Git commit? Probably not. But that's a weird way. One of those areas where the semantics that we have for web development or traditional kind of code pipelines doesn't really fit into something that also is very dependent on infrastructure.
Good.
So you mentioned obviously one of the key issues with training large machine learning models is the amount of time it takes. And so you mentioned like for a regular web app, the build time is usually pretty short. Do you encounter any specific problems where like you've been running your model for like 2.5 weeks and then some like test that comes in at like for some reason at a later stage breaks, and there are thoughts on how to prevent that or be able to foresee where something might fail ahead of time?
Yeah, I think I don't think there's like a single answer to that, but I think that what you're asking is the type of thing that needs to be part of this, kind of emerging syntax. So, for example, like you don't really like your web app fails or it succeeds in building, or the tests fail, or they don't, or they pass. In these systems, it could be succeeding for a week and a half and then fail, and so that's an area where you actually want, a system for, for the pipeline to kind of accommodate those situations, because they're expensive. Like you're training something on, 100 GPUs, that's really expensive. So I don't think, generally you can like stop training something once something diverts from what your expected, model how it would perform. But that's like one of the central things, I think, that as this emerges, what you're going to see is a kind of core piece of these semantics.
One last quick one.
So in the beginning, you mentioned that web applications, as an example of CI/CD deployment pipeline, right? You create a feature, and then the feature goes out immediately. In the ML and the AI space, a lot of features aren't necessary to be immediately deployed. An example might be if Netflix is making recommendations for you, they don't necessarily care about making them in real time. So how does that fit into the model of what you're building? And is your solution a non-real-time solution? How does it differ from the traditional model?
I think the most solutions, so we, kind of help other companies build out these pipelines. We actually don't generally build them out ourselves. And I would say most of them are based around sort of batch training or, refitting a model once a week. I think that the goal is to get to a real-time, continuous kind of self-learning model. I think has been super elusive for a lot of reasons. One is that compute's expensive, the algorithms are new, the frameworks are also very new, but also just that the tooling doesn't quite exist yet. So, if you find companies that are doing deep learning that have staging, development, and master branches, that's already like light years ahead of, I would say, 99% of the companies that will be using this technology in 5 years.
Cool. On this note, Dillon, thank you so much. Really
Thank you so
appreciate
much.
it.